As I mentioned earlier, there are alternatives to the principal component analysis, and the main alternatives that I'm going to consider, but not explain, are exploratory factor analysis and confirmatory factor analysis. So the one that is closer to principal component analysis is exploratory factor analysis, and the only difference is that the equations that are used, the mathematical equations, in principal component analysis, we've got for an equation in which the component is explained by the variables weighted by the weights or the loadings. So there will be one loading for each a variable, and these are added, and then that explains the component. So it's a linear combination of variables or items with the weights or loadings. So it's very similar to regression, whereas instead of in regression we get the regression coefficients, here we've got the factor loadings. And the difference with regression is that in regression the dependent or outcome variable is a measure variable, whereas in this case it's not. So in exploratory factor analysis, what we are trying to predict is the values of the variables rather than the values of the components. And then we use what we do is we do give weightings to the factors, which are equivalent to the components in principal component analysis. So we give weightings to the factors rather than to the variables. Now, the results are typically very, very similar in principal component analysis and exploratory factor analysis, but mathematically they are quite different. So, and also I've been warning that in principal component analysis we get the arrows from the items to the to the components. In exploratory factor analysis we've got the arrows from the factors to the items, but this shouldn't be taken as a causal model. These are graphical representations of statistical models. So basically exploratory factor analysis and principal component analysis are similar. They provide same information, and we can use them. We can use both when we want to extract some latent variables from the data. Now, confirmatory factor analysis is in the exploratory factor analysis family, but the difference is that instead of letting the software to calculate or determine the number of components or factors and the factor loadings to and the selection of the variables that correspond to each of the components or factors, that is done before the analysis. So instead of letting the software to decide which variables load into which component, we tell the software what we believe is the case. So we believe that, let's say, items 1, 2, and 3 load into factor 1, items 4, 5, 6, 7, and 8 load into factor 2. So instead of exploring, we are testing whether our theory, expressed in the form of a confirmatory factor analysis, is correct or not. So the model that we are proposing with a certain number of components or factors, and which items or variables load into which factor. Is that a good model of the data or not? So that's what confirmatory factor analysis does.